So for today's session, I've kept this topic, talking about the introduction, that part we have just completed. We'll talk about something called variable constant. We'll talk about data types. We'll talk about operators. We'll talk about basics of DSA, then loops, then pattern printing question. Okay. Just for your understanding, this entire course is language agnostic. What do you mean by language agnostic? But before I go there, let me start with that. What is your favorite language to code? Just mention in the chat. Java, Golang, C++, Python, whatever that is, just code in the chat. C Sharp, okay. Java, JavaScript, Python, C Sharp. Okay. Anybody else who is yet to answer? C Sharp, okay. All good. I think majority of you have answered. C, Java, Java and TypeScript. I'm just curious, the people who are writing C, what exactly you are coding in C? Because C is used, nowadays C is only used on the platform level. So what exactly are you using C for? Golang, okay. Java, TypeScript. Okay, sounds good. So the three main languages or the three high-level languages that I've got from here is Java, not Golang, Python, and then some of you have C++ and some of you have C Sharp. And of course, there are other languages as well. Okay. Now, for the purpose of this course, we are going to keep this in language agnostic. Yeah, embedded systems and stuff. Makes sense. For the purpose of this course, we're going to keep it language agnostic. Means you can code the same thing in C++, Java. Mostly we'll be going for Java because majority of our Java developers, but that does not mean we'll just not discuss other solution. We'll just see the code in C++, we'll see the code in Java. If we want, we can go in Scala as well. Okay. And of course, see Python and other languages. Okay. Majority I'll keep it for Java because pretty much most of you, at least 80% of you are Java developers here. But that being said, if you are from some other language and you want me to write that code in that language, I'm happy to do so. Okay. All right. I don't want to make this course any language specific. So this is language agnostic. That's what I wanted to clarify for. And those who don't know, your DSA interviews are going to be language agnostic. It's your choice in your programming interviews or in your DSA interviews, however you want to write the code. Exception might be there in case the role is for a specific developer. For example, if it's a Java developer role, they would expect you to code in Java for DSA questions. But in overall, you will not be expected to write in a particular language. As long as you write a good readable code, production ready code, you're good to go. Okay, cool. Now let's start with our favorite topic or the course that we have is DSA. Now DSA is a combination of two terms. First part is called data structures. Second part is called algorithms. Okay. See, some of you are right. Some of you are right in the sense, not precise. Some of you are close in terms of what the definition is. And again, when I say definition, I don't want any bookish definition. I don't even appreciate booking definition. It's the understanding of the concept or whatever thing that you're learning that you should be clear with. Okay. So let's understand what is a data structure, what is the algorithm as per theoretical definition. And then we'll take a practical example to make sure we are clear with that. And then we'll circle back to it. Okay. Starting with number one, what is a data structure? If you look at it, it's a combination of two words. One is a data and one is a structure. So it is just a containers which are used to store data to perform operations on it. Data structures are just the containers which are used to store data to perform operations on it. Okay. Examples of that include arrays, linked lists, stacks, queues, trees, graphs, maps, sets, tries, RBTs, etc., etc. All of these are data structure. What is algorithm? Algorithm is a step-by-step process to solve any task, or you can call it as a problem, using appropriate data structure. Okay. Examples of algorithm include dynamic programming, which you call as DP, recursion, divide and conquer. What else? Backtracking, searching, greedy, heap, not heap exactly, but sorting, hashing, etc. All of these are algorithms. So just to go to the definition again, a data structure, as the term says, it's a data structure, means just a container in which you're going to store data and you can perform operations on it. Okay, operations can be of any type. It can be search, it can be insert, it can be delete, it can be traversing. Okay. Example includes your array, linked list, stack, queues, graphs, trees, maps, sets, etc. etc. In the case of algorithms, algorithm is a step-by-step process. How do you solve any task? Okay. And of course, algorithm is not dependent upon data structure. For example, if you talk about dynamic programming can use any kind of data structure. If you talk about recursion can use any kind of data structure. Divide and conquer can use anything. Backtracking can use anything. Searching can use anything. Okay. Algorithm is not dependent upon data structure. It's just a process. How do you solve a particular task or a problem statement using the appropriate data structure? This part is still clear to all. This definition crystal clear to all. Then I'll come to the practical part. Okay, cool. I see one question in the chat. Every program doesn't have an algorithm, but an algorithm can be changed into programs. Yes. See, program and algorithm are two things. Algorithm is a step-by-step process. Program is what you write it using code. Searching is not a code. Searching is an algorithm. Somebody wrote the code like linear search and binary search. They were first a theory. They were first approach, right? And then you convert it into whatever language of your choice. Okay. Now, this is the definition. Let's talk about a practical example. So to make sure that we are 100% clear with it. Okay. So I'm just going to make it super practical for you guys so you can relate. Algorithm is a higher abstraction. Yes. Now, in terms of a practical example, I'm going to give you a task. The task is you have, let's say, 20 liters of water. Okay. And you're given some resources. Resources in the sense you have 5 buckets. And let's say the capacity of each bucket is 10 liter, each of them. Now let's start with the very first question. The task is, what are the ways to store water in buckets? You're given a task of 20 liters where you have 20 liters of water. The resources is you're given 5 buckets, each with a capacity of 10 liter. You have a task, you have to identify what are the ways to store water in buckets. Okay. Of course, there can be multiple ways. Now let's start with the very first thing. Can you store 20 liters of water in these 5 buckets, each with capacity of 10 liter? Is it possible to do that? Okay, it's possible to do that. Now, what are the different ways to do that? Let me know. And then we'll talk about something else as well. If you have to solve this task, how will you solve this task? Whatever ways that you have, let me know. 10 into 2. Okay. Any other way? Any other way? 5 into 4. Okay. Any other way? There are millions of ways to solve this problem, right? Let's start with common 2 ways. The first way is I can use 2 buckets, 10 liter, 10 liter, and I can keep rest of them as empty. Simple way to do it. Okay. Or I can do it another way where I can distribute the load. I can make it, let's say 4 liter, copy this, paste, B2, B3, B4, B5. Okay. And there are multiple other ways to solve this question. I'll just type it as many other ways. Now, understand one thing. Why did I take this example? What am I getting from this example? What is the purpose of bucket? What is the purpose of bucket? The purpose of bucket is storing the data, okay? Or storing the water, let's say. And what is the ways? These are the ways to solve the task, whatever task that is given to you. Now look back. In this example, look at the example again and then relate to the data structures and algorithm. You are given a task where you need to store 20 liters of water, okay? The ways that you solve it, there are multiple ways. This is one of the ways to do it. This is second way to do it. And then we can discuss which one is a better way out of it. Okay, that's a separate discussion, but there are many ways to do it. In this example, what are you storing? That is your data. Where are you storing? That is your data structure, basically a container. And how are you storing? That is the algorithm. Everybody clear with this part? Does that give clarity to everybody in understanding what is a data structure, what is algorithm? I'll repeat it again. Look back to the theory definition and then go back to the practical example. Theoretical definition says whatever you want to store, that is a data, because data you need to store somewhere. Where do you store? Wherever you store, that is called a container. So container which is used to store data so that you can perform operations on it. Multiple operations are possible. Algorithm is the step-by-step process. How do you solve a particular task? Okay, you can use appropriate data structure for it. Now coming back to this example that I've taken here, what I was storing water, that is my data. Where I was storing in the bucket, that becomes my data structures. How I'm storing it, that becomes my algorithm. Everybody is still clear with this, theoretical and practical? Okay. Now one more thing, which is not relevant to this, but it's good to talk about. When we say algorithm, we usually talk about optimize, less optimize, more optimize, right? What do you mean by optimization here? Optimization can be related to time complexity, optimization can be related to space complexity. So optimization is just what is a better way of doing things, correct? So if I take an example of this, let's talk about these two ways. In first way, I'm keeping the two buckets. In second way, I'm using all the five buckets. What, in your opinion, is a better way to do it? The first way or the second way? And give the reason also. What, in your opinion, is a better way? Is the first way better or the second way better? And give the reason as well. Okay. Well, if you look at it, it can be seen and justified in multiple ways. First way, the one thing that I'm really good is I am efficiently using all the resources. Okay. What do you mean by efficient using all the resources? If I have, let's say, 5 servers and something can be done by 2 servers, why should I waste other 3 servers? Okay. Even if you don't want to call it server, call it whatever you want. If you can do something with five, if you can do something with 2 things, why do you need to include all 5 things in that? Okay, that's one way of looking at it. Second way, you can consider it as a wastage of resources, or you can also look at as, just equally splitting the distribution here. So it can be perceived in different ways. I'm not going into that details, but what I want to make clear is, if I talk about space complexity or space optimization, first way is more efficient than the second way. Agree? Imagine if you have to put these buckets, the first approach will require only 2 buckets. The second approach will require 5 buckets to store. And obviously 2 buckets will take less space than 5 buckets. This is what you call as optimization, or comparing across different algorithms. Comparing across different algorithms. Okay, cool. So we talked about the definition of data structures and algorithm. We talked about the theoretical one, then we move to the practical one, and then we just map it back again to the theoretical one. Okay. I believe everybody is crystal clear with this. Yes, that is what optimization is. Okay. Now we move to our next topic, which is understanding variable and constant.